We're tagging you in, Joyce.
Ready, set, go.
So familiar.
Oh, this is one of the ones.
Ah!
2008.
We did 2011 yesterday.
Dang.
We did this one, though,
This
didn't
was
we?
not a test.
Yeah. How do you do it?
Right.
I did it wrong, so...
You
Well, we did a LeBron's one yesterday.
Oh, you see, I
No,
know you throw
no,
cards.
I did it wrong the first
So I
time.
would still put it on over the factorial, right? The coefficient
Huh?
of
What? What?
The coefficient of whatever prime, whoever
For
it's
C?
centered, for A.
Mm.
At the first degree, we're about 2, so I would do the coefficient of H prime,
So
of
it's
H
easy.
double prime over 2 factorial, right?
Of H double prime? Yes. H double prime will be over 2 factorial because you are making the polynomial using the formula. Does that make
Alright.
sense?
So you just put those numbers into the formula. And then you approximate with 1.9.
But you're doing a first degree, so you're not even going to H double prime.
Right. No.
But if you were, then yeah.
Well,
Okay, so that's A. You form using H of, what is it? 2? Yeah.
H about 2.
H of 2 plus,
Well,
oh, about 2?
you're right. Yeah. So it's just X minus 2, so you would use H double prime of 2.
Oh, right. So it'd be H of 2 plus H prime of 2 times X minus 2 times, and then if you were to keep going, H double prime of 2 over 2 factorial times X minus 2 squared.
when
But you're stopping here, which, Amanda, you know this. What am I going to say that this is just the first degree Taylor polynomial is the same thing as?
He is the one.
Yeah. Oh, you do it for Euler's method.
Oh, y equals mx.
Yeah, it's just a tangent line,
Yeah, it is.
right? Anyway, so that's just using the equation of the tangent line. But first degree, go ahead and plug in 1.9. Greater or less than? How do we
the function is strictly increasing on
Define
that
that one.
level.
Wait, where are we?
well for the whether the approximation plugged into the Taylor is going to be greater than or less than?
From the first derivative in
We
the
have to see concavity. Because if it's concave up like a cup, never mind, that was dumb. No, I think it has to do with concavity.
Well, it's strictly increasing because the values of h are getting bigger, and the derivative is all positive values. So it is increasing constantly.
The derivative
Don't say it.
Sorry, the function h is increasing constantly.
The function n? The function h? Because it could be the function of the derivative or the second derivative function.
If I write that on the AP, will they mark me down for saying the function?
But it's not because h is increasing, it's because h prime is increasing or h double prime is positive.
So it's
You
like
can do it
under,
either way.
so it's an under approximation?
The approximation is an under approximation since h prime is increasing. Why does that make sense?
Because the
Concavity is up. So the tangent line will be concave. If it's concave up, the tangent line will be under.
Yeah, so your concavity was right. They just didn't say concavity specifically. They were saying h prime is increasing.
Could we say
Because at 1.9, we can't say what h double prime is. Does that make sense? So we can't state concavity based on this chart because we're doing it at 1.8.
wait, what?
No. We're doing our tangent line at,
At 1.9, between 1.9 and 2 is
2.
positive.
wait, sorry, we're doing it at 2. So at 2, we could use h double prime of 2 as positive.
And even at 1.9 by IDT.
But 1.9 is the plugging in, right? So we don't need to worry about 1.9. Well,
Because
because they could go up and down, up and down, up and down.
because of the increasing clue, yes. Because of the increasing clue, we can say that they're all going to be positive since that one's positive, that one's positive, strictly increasing. We can say that. Okay.
Well, would it be safer to say, since h prime is increasing, the function is concave up and the tangent line would be an under approximation? That'd be a valid.
Yeah, so they didn't identify it as a tangent line. What I was saying is if we have a second degree or third degree, we're not going to be able to use the tangent line idea. Does that make sense?
Yeah.
So that's why I was trying to make it a little bit broader. I've been pondering making another endeavor card on because I saw this as a little bit of a weakness. You guys have no. You haven't gotten your multiple choice questions back, and
No.
Jackie needs your AP final.
we all got them except for, I think, Jack.
For the over and under approximations.
I did.
Oh, yeah, we did.
Yeah, we did. Got our multiple choice back, but
Was it Jackie? I don't know.
But Joyce and Amanda didn't get their multiple choice because I forgot. Hey Deb, here's your multiple choice ones. Jackie, here's your whole shebang. And then Joyce needs. Joyce, I'm gonna put it on my desk. Nope, I'm gonna put it on the TA desk. Your multiple choice from the AP final.
But you probably already have it by now. Joyce does.
Oh, sure. That's true. Because she usually finds it before I.
Yeah, I think fourth dimension.
Dun-dun-dun. But I was thinking about making it with over and under approximations because you have. What are the different over under approximations they're going to ask us about?
Riemann sums,
Riemann sums. How do you know about Riemann sums?
depending on the way
Increasing or decreasing the function that you're taking.
It's a right or a left.
And it's a right or a
or
left.
midpoint.
Or midpoint? They have, I haven't seen them ask the midpoint, but yes, or the midpoint.
Hypothetically.
The midpoint, can we really tell if it's over? or
Yeah,
under?
that's the thing.
With concavity. If we have a concave up, this is gonna go up and then out, right? And then the next one's gonna go up and then out. We're gonna have a little.
But because the midpoint is the midpoint of the x's, not the y's, it's not necessarily in the middle of the heights. Does that make sense?
Yeah.
So the shapes could be totally different sizes.
Oh, yeah.
That's why I think the midpoint we can't actually, without considering the actual function. That's a good question. I don't know about that one. Left, right, trapezoid. They could ask us about all of those.
Right?
Because trapezoid we could do with increasing, decreasing. also.
How can we did trapezoid sums instead of?
Oh, no. What's something else though, over and under approximate?
Oilers. They asked Oilers.
Whether or not it was an over and under approximation.
All the ones he gave us recently. Oh, for the Euler thing, he asked is it an over or under.
Oh, we haven't gone over that yet. Okay, we'll peek at that. I actually didn't realize that they would ask it for Eulers. I was thinking tangent lines and I was thinking nth degree to their polynomials. That's what I was thinking. So maybe we should summarize that in Endeavor card, but I guess we'll check out the Eulers first.
Sums, it's increasing,
Sums?
decreasing, right? Not concavely.
So tangent lines, concavity. Riemann sums is increasing or decreasing depending on left or right. Same with trapezoidal. And then with nth degree Taylor polynomials, it's depending on
Yeah, it's hard to tell the concavity with this thing.
well, 1.9 is below 2. H prime is increasing, meaning the rate or the slope. The derivative of H prime is going to be higher than it should have been. Does that make sense? Wait, that doesn't make sense.
H triple prime is in, all of them are increasing.
All of them
H
are
prime,
increasing.
H triple prime, H triple prime.
So it's
Which means it's gonna be increasing concave up all the positive things.
Is H the approximation? No, P1 is the approximation, right? H is approximately P1, so they're saying it's an under approximation because H prime is increasing.
Can't we just say concave up in the under approximation, concave down?
Yeah,
over
but what
approximation?
if it's a second degree Taylor polynomial?
Wrap it.
I think no, we're still going to use concavity ultimately. Because depending on the concavity, if it's concave down, it's not going to skim by cutting through, it's going to skim like a tangent line and cut above. Okay, that's true. That's true. We can still use concavity.
Yay!
It's like a tangent line skimming. So Riemann sums are the only weird ones with the increasing, decreasing. This one though, since concavity, we couldn't. No, we could have pulled out of the graph, but they chose to use the increasing clue of H prime to talk about the concavity.
Yay! So it's
So
increasing, therefore concave up, therefore under approximation.
So in letter B, the third degree Taylor polynomial approximation is going to be an over. No, it's going to be an under approximate as well, right?
Yeah.
Okay. Question, letter C. That's the one I was actually asking about the good topics on A and B because I was actually thinking about the over and under approximations and summarizing for you guys.
They tell us it's increasing, so we don't have to state IDT, right?
For letter C,
For A.
IDT. No, they didn't ask us to explain
I would
IDT.
just because.
Yeah.
IDT.
Because you would say because it's increasing, so it can't be 0. Or no, it would be the other way. That's why it would have to be.
It can't be there. What's it?
I mean, so I would say like since the function h of x is increasing from 11 to 80, that means the function h of x, that zero word, I was gonna say it would be like it would have to be greater than 11, so it has to be increasing, which would mean that it doesn't because it doesn't work. Because
Yeah,
it
it's
could be
only
going-
based on.
yeah.
Yeah, it's only based on the wording. So for letter C, Lagrange, what's the formula of Lagrange?
R sub whatever is
Well, hold on, we know third
Absolute.
degree to the polynomial.
R sub 3
Absolute value of the fourth derivative over 4 factorial times x minus 2 to the fourth power.
mean our max.
Why are we doing 4?
Less than or equal to.
But we're not doing F, we're doing H, I apologize.
Because it's the n plus
So
first
H4 of, or you can write the max of H fourth of x all over 4 factorial times x minus what? 2 to the fourth, but it's not x because what are we plugging in?
1.9.
1.9.
And we pause it because 4 isn't even.
Because boy, how do we maximize H?
So you need to figure out the fourth derivative of H, the maximum value. On what interval?
1 to 3? No.
1.9 to 2.
Because remember you go from what you're approximating at
So
to where you're centered about.
584 over 9.
Because it's considerably increasing.
Because, exactly, and that's where a lot of you guys messed up your points is because they want to see you doing the maximizing. So then a lot of you just like plug that in, but the reason is because is since, now this is why I don't like it, because I wish that if they gave a point for the explanation, even though they didn't say explain why Lagrange is maximized. But I think they thought they would have been giving it away. But they gave a point based upon, I'll show you the answer key in a second, based upon you saying since the fourth derivative, since h to the fourth is strictly increasing, then the maximum of h to the fourth of x on 1.92 is 584 over 9. So they want you to actually show in Lagrange not only the number, because it's like the one that you can choose, but to actually say why. So then you go ahead and plug in your 584 all over 9, all over 4 factorial. That's all positive, right? And that would go ahead and be,
Negative 0.1.
didn't you technically just do?
Stick to the
What
middle.
are you trying to say?
Less than 3.1.
How do we know what it is?
Just say it.
And then if it's not, would they ever do that to us?
Well, if it's not, well, they say use to show, so you know it's going to work out. You could go ahead and simplify and prove it to yourself, and if you go through and simplify and it's not, then you've done something wrong in your setup. I mean, I guess you do
Would they
that,
ever
but-
charge you like, oh, it's not, so we have to put like the, it's not less than, equal to like the slash root less than, you know what I mean?
No, because Lagrange is going to be,
But is it for sure that it's less than 3 times the limit?
because they say you use Lagrange error bound in order to show. Instead of saying it's a fact, in order to show why. If you guys notice the formula Lagrange error estimate, that's that, but then they say the reasoning.
What's the reason? Oh, so their formula was wrong.
I took it to mean the reasoning was that H is increasing, therefore you're able to plug in 584, which is less. But if you notice, I mean, you can't do that in your head, right? This is question number 3. It's a non-calculator FRQ. To go from this to this and stuff. True? Okay. So you guys need to take it to heart a little more. The stick it to the man. We talked about it yesterday after school. Those of you guys that were in here, those of you that weren't. Take it to heart, the stick it to the man. It's important. Otherwise, if you did any wrong step in simplifying this, even if it was still less than, if you got something else, if you wrote something improper or incorrect, they'd have to take off the point, and that would stink. Alright, we saw a Lagrange thingy. Let me get out of this full screen. And pew, pew.
Christy, with the test corrections, you want us to correct them on the test
Multiple
itself?
choice itself, yeah.
Oh, not the FRQs?
Cool.
FRQs, the answer key, we already went through, so it's up to you guys. I mean, it's great for you guys to correct the FRQs, but I would, I don't want you guys just copying from the answer key. I'm not really sure if that's helpful. So,
So then also.
and I try to give detail. Remember, like on the AB FRQs, I'm gonna make them correct because we didn't show any detail. But on your guys's, I tried to point out your mistakes. So I would just say look over the FRQs, but the corrections on the AP exam due after spring break are going to be on the multiple choice, and you can correct them in the multiple choice themselves.
You want us to explain why we got it wrong?
You don't have to do that sheet at all. Just show me how to get it right. Does that make sense?
Sure.
And then you'll just turn in the Scantron. Well, you'll probably just turn in the whole thing, and I'll just check. Am I collecting it Wednesday?
Is it Wednesday?
Yeah, I'm collecting it Wednesday. I think for recording
So-
is due on Monday.
The video's tomorrow.
Video video is due, I said that at the end of the week, I gave you a little bit of extension. I scanned the wrong copies of the FRQs. So instead of giving you guys the chili powder ones that weren't even applicable, I need to scan the right copies of the FRQs for AW wanted it and John wanted it. Cool kids, with that, let's grab out our logistic and Oilers packet. Any other questions?
There was one more question I had, but I can't remember what it was.
Drop it in there, don't even worry about that sheet, so no explanation necessary to see if you can figure out how to get it right. Returning in your Scantron with your multiple choice so that I know how many you missed and whether or not you fully corrected.
Did we ever turn in this one? So that's supposed to be.
No, that was another logistic for today. We're gonna turn that. I think I gave you guys like a day of grace and we just never turned it in. Then Joyce gave it to me yesterday, like, hey, I forgot to turn it in. I was like, oh, we all did.
So
Go
I'm
up
just gonna
to
keep it in.
We told us it would be due Tuesday.
and then I was just giving lots of grace, yeah.
And then today, yeah, then you said like there was gonna be no homework on Tuesday night.
Exactly.
like-
We didn't have any homework.
Exactly.
See?
So like.
So then I'll just collect 1 and 2 tomorrow. We've done 1, I think. Did we work on it together and went over all the questions that we had on there?
One? Yeah, you already
feel
put
like
the
we
grade in, I thought. Learning foundations one. You put the grade
I
in.
think I spot checked it in class.
Yeah,
Was
you
that-
spot
oh,
checked
yes.
it.
Oh, and I didn't spot check Joyce's. That's why she used.
Okay, so that one we
Sorry.
tried first.
So that one, you're good. So then we're on this one, the logistic one. How many of you guys have actual questions on the logistic and Oilers method from the weekend?
See, I didn't realize we were doing this one, so.
I did it yesterday morning when I wasn't here, but I still have questions.
When you weren't here.
I got here at 4.
Oh, I didn't know.
So I have a
Oh, at all?
I hear form one.
Oh, yeah, because you were gone on Friday. That makes sense.
No, I got here
Here,
4.
Jackie.
Oh.
4 period.
I had one for you.
I don't know why we do this.
It sounds like, what do you do?
Yeah, I really, I don't know.
You did your project, didn't you?
That did happen.
That's it.
I gotta get cracking on that.
Alright, if you guys want, you can just go ahead and start working, and I'll go over Gerardo's questions. If you want to like listen along, you totally can. Just jump around to the ones that you got stuck on. Did you find the answer key online?
Then I was looking through my Google Drive and I'm like, what did but it's
It should have been under handouts and then
yeah,
keys.
it was I think it was in that section by mistake.
Oh, this is so hard. I quit.
I think I got one right. We were no. Let me pull it up.
Hold on, look at the teachers. I'm not saying you can know, that's what I was asking. Here you go. You guys want to take a picture of the answers?
I'll take it this time.
Sorry,
I think
George.
Gerardo took it last time and we did not get good pictures. So somebody will think of like good quality ones to send them to the group chat.
Ready for the next page?
Wait, no, somebody's already taken it.
Alright, we'll make them.
Hey, good. Next page? Just the answers, right? Is that okay?
Yikes. There's only one for your response.
Ooh, logistic. Go team.
But that was an even.
Yes. But I give you bonus instead, and it's not too just And then if you guys want, this does show you some good old FRQs to look at. No, like on. Hey, can I take a picture of this?
Georgie.
Because they're all wanting to. I'm not saying you have to do those. I'm saying when the AP's coming, you're like, oh, logistic and Oilers. Oh, that's right. There are those 3 FRQs. I can just find them.
I don't know,
Pardon me,
somebody yesterday told me I didn't have to know everything. It was okay if I got some of it wrong. Don't know who it was, but it was somebody I know.
But you got some of it wrong that you could get right, and then it gives you more of a cushion if it gets tricky.
I'm just saying.
Sam likes the
Yeah, it ruins our IMAs.
Yeah,
we can take
him
I haven't really wanted to. We can't kick him out. We have to create a new one, don't we?
not
You can respond to it.
I don't think he gets them.
I think you put us on Do Not Disturb, probably.
No, he doesn't. He doesn't have an iPhone. That's why we're. That's why.
Now we can actually
I
like
know.
name it too.
I know.
There you go.
I was like,
We can
And
we
then
do
so
it
But
so
you can't
far-
search by the name, and that really annoys me. I still have to search for people.
no.
It doesn't work on my
It
phone.
doesn't work
You
on my
try
phone
it.
either.
I don't know why. It's
Alright.
so annoying.
to make the
you
name
not? I thought you
CalcBC
said.
pseudo
With my
concept.
DR cool kids, I can't search for
Sounds
them.
like CalcBC.
CalcBC kiddos.
There you go.
Have to be the cool.
Startup, what questions do you have?
Alright, so 1 I got right, 3 I got wrong.
I don't know.
I don't know.
Okay, so we'll start with 3.
do I have to do this in a different color?
Oh, you're right. I guess I just said student council within the student.
Yeah,
council.
that's what I used to think too.
Huh.
And I was like, oh. It's like when I would look up DR Cool Kid, it would be.
Yeah, but I have to look
Wouldn't
up someone's
be-
name and I have to like scroll through because like Georgie's in all of my.
If I have to think of someone who's only in the one group chat.
Yeah.
then it's okay.
Like I just typed into DR Cool Kid, and then, like it
Right,
shows
that's
up with one of your messages. That's what gets me to the thing, which is like interesting.
So you guys get it, right?
Yeah.
I haven't looked.
I
Okay.
think there's cool little
No.
SETI thingies.
Yeah.
It's all your fault. Number 3, which must be true.
All of us, just because you all love.
2 and 3. That's the answer says.
Okay, 2 and 3.
No, no, seriously though. I figured out 2.
The approximation.
Okay,
we have information up above, right?
Yeah.
F of 2 equals 1, the derivative of f equals 2x f of x. And the second derivative is positive. So I have a formula or a function for the first derivative. I know that I have a positive second derivative.
That means that it's concave up, so it's going to be under approximation. So, and then interval 1 to 4.
Wait, you got 2. What was your answer? 2 on?
I got B on because I couldn't tell if 3 was right or wrong.
Because Euler's makes sense, right, for thinking tangent lines to concavity, right? Because we're doing all tangent lines for Euler's method, and so if I have concave up, like that shows Euler's going to be under.
Same thing. Wait, why is your question different?
K, Y. Y
Number 3 is
equals
different?
C,
No,
D.
no, no.
Oh, I'm not showing number 1, sorry. Number 1's up there.
Oh, the information.
Yeah,
Oh,
I'm
oh,
showing the information because it's true for 2 and 3.
I thought the information was for 1.
I don't know, that's just the thing I don't get. There's like this, the formula is Y equals C to the KT. There's no T.
The approximation, it says on the interval 1 to
Yes.
4, the approximation using Euler's method is too small using x step size. Delta x is too small, meaning under approximation. Okay, sorry, I was still on 2. And then 3 on the interval 1 to 4 for the specific function, f of x is equal to c e to the x squared. No, this is not dealing with exponential growth and decay. This is dealing with this derivative of this form. The derivative of a function is itself times 2x. That's only possible if I have e to the u and du or u prime is 2x, which does work for this function. Does that make sense?
So 2 and 3 are true?
So why is the C there? Why?
Well, there's a constant integration. Who knows what c is, right?
Okay. Why wouldn't it be plus C?
When you multiply by e.
It'd be e to the x squared.
So the way I would think about it would be is if I would make the f of x y, so I would have dy dx equals 2x times y, and we have to integrate by dividing the y over and multiplying the dx over, and then integrate you would have ln of y,
Oh,
our
right.
absolute value of y equals equal x squared.
Oh, you didn't actually solve in
Yeah,
differential
that's
equation.
all I would do.
Oh, okay, I
You
agree
know
with
what I
that.
mean?
It'd be dy over y equals 2x dx.
And then integrate, you get absolute ln absolute value of y equals x squared plus c, and then you would e it and e
And
it.
remember,
Yeah.
the addition in the exponent is multiplication. So e to the x squared times e to the c.
So that's what.
Um,
E to the c is a constant, so we can just say c.
Yeah.
But if you think about it just logically, like the testing, because I tend to do that as far as like multiple choice going fast. If the derivative equals the same function, it only works with e to the. Now, if the second derivative equals the same, that can be trigonometric as well. But first derivative, I have to have e to the, and so it can be offset by a constant. If it was plus c, oh, you're saying it should have been plus c instead of times c. Okay, I understand. So then 2 and 3 are true? Dun, 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 dun,
Dun,
dun.
dun.
Any other ones?
Yes. Of course.
Bring it back when I'll think of it.
I can check that. I can check that one, I guess.
You should ask all the questions.
George,
All
same
the
as
same.
Twice. Just ask every
1D.
single one of that.
FERC 1D. Can we please call them FERCs? That would be so awesome.
Oh, sounds so much better. I can call back a mile. You're given f prime between 0 and 5, and you're given an initial condition f of 2 equals 4. Explain why the approximation in part A, which is Euler's method, must be larger than the actual answer.
I put the.
Oh, it's graphing calculator. Can't you find and derive at the point? What are we using?
I put because concave down, but I was like, huh? Yeah, it is concave down.
How do you know?
Well, the derivative was negative.
The derivative of
On the entire interval,
You took the derivative of prime?
At the point.
2 to 2.4.
Oh, I
You
looked
say
at,
for the entire interval,
Oh,
because
I
you're
looked-
using multiple tangent
yeah,
lines.
I looked at the graph. It was going like this.
But did you look at this graph? Or
Yeah.
did you write this?
No, I looked at that graph.
Okay, well that's not gonna count.
But if you look at the slopes of that graph, if that graph is decreasing, then you can make
The
that statement.
slopes are
Yes.
not if the actual
No.
time is negative.
Yeah.
That's it.
Yeah, it was going like this, and it looked like a flat line, but I'm like, I'm
So
sure.
slopes are negative, the prime is decreasing. Be careful of your terminology. So the slopes are negative
Yeah,
on the interval 2 to 2.4.
that's what I got. I'm not.
F
100%
prime
sure.
is decreasing. No, that works. Because they're tangent lines, so you need to figure out the concavity.
Let's double check though, just in case. I actually think I still have it saved on my calculator. Saves a little bit of time.
Oh, the actual
Oh,
graph.
here it is. Yeah.
I thought you were double checking the answer.
So what is the answer? Concave down, that's right.
But what I was saying in Gerardo is that you need to stay on the entire interval. Because it's not enough just at one point since there are multiple tangent lines being computed with Eulers. Does that make sense?
Oh, that's weird. Because at 2.4. Let me check again.
If it says too large, I would just say
Oh,
over
it is.
approximation.
Yeah, derivative at 2.4. Okay. Because.
And crazy enough, they didn't really even explain much. I would have said that F prime is decreasing on the interval, therefore F double prime, which implies F double prime is negative, which implies F is concave down, so we have an over approximation. Say over approximation, don't say too large.
5.168, 5.136, and 5.2. Yay, they're all right. First try.
Anything else, or you guys are trying to work? I don't know. It's still like 10 minutes, so we
It's been a while since we've done this. Would you mind doing number 7?
Oh, and 13 too.
Yeah, that's the one that
Okay, so we're using,
20.
how do I know this fits logistic?
Because that's the other form.
What other
Yeah.
one?
Logistic.
If you take out a P and take out 0.01, yeah, then it's something like
KL times L minus Y. Or KY times L minus Y.
So if we pull out a 0.1, so 0.1
No,
times P, we
No,
would have,
O1. That way the P will be alone. Oh, sorry.
oh, you mean the P squared, isn't it?
Yeah, that way.
Oh, got it. I can backtrack very well. That was working. PPT.
It'll be alone. No, it'd be under minus P. If you think about it, George, it'd be under minus P.
So I have my K times L minus Y, right?
Oh, yeah, right. Oh, shut that.
Internet?
Shouldn't that be? It must be scary hearing that from your parents.
No, my parents say that.
No, I feel like if you're Hebrew and your parents do that, you should smack on the head for it.
Okay, hold on, can we talk about all of them, just because it's logistic and we haven't done logistic at all in a while?
yeah.
So number 6, if the initial population is 150, what's the population as T approaches infinity?
100.
Why?
Because that's
It's a limiting constant. So remember we have K, Y times L minus Y. We're thinking about the logistic growth. L is a limiting constant. If the initial population is 20, what is the population at T equals 4? Oh, nasty. So we have to solve that differential equation? Heck no, techno.
No, L equals. No, I don't know. What am
P of T equals lice.
I? Minus late.
So remember L goes on top. I stands for 1
plus.
plus CE to the negative LKT. What's L times K?
We don't know.
0.1,
Times 100.
because we have K,
Oh, yeah.
right? L times K is just what happens when you multiply the K and the L, which is the 0.1, so we have the 0.1 LICE minus LK, and then there's our T. But they said T equals 4, so all we have to do is plug in.
Oh, with the calculator. We get it.
T equals 4, and then we have to set everything equal to the population, which is
27.
20. Oh wait, what is the
That's
population of 4?
So C is 20?
No, C is
No,
4.
I need to plug in 0, not 4. Because it's our initial, so when time equals 0, which is going to make,
That's gonna be 1. Wait, what's our C?
4.
because solving for C.
C is 4.
We're solving for C right now.
So then e to the 0 is just 1.
Why did I let this
Multiply, so I have 1 plus C equals 100 over 20, which is 5 minus 1.
So it does end up being 4.
Did you ever teach Gina how to switch rows on the calculator?
No.
1 plus 4 e to the negative 0.1 times 4. There we go. Then you got, what's our C? Proper?
Yeah.
Does that make sense?
If I was science class, then no.
So then number 8 says, hey, let's give you a lice minus lift and have you go to the differential equation.
Oh, shoot.
I feel like the only one that makes sense is, well, the right form is number 1, right?
True, but you have to make sure, because it's which of the following could. See how there's multiple?
Ooh, it could also be 3.
How could you check?
You can divide out the 0.08 from the.
Couldn't you just distribute them all and see which ones match?
do I have to direct this? How does the function work again?
Not for number 8, because there's decimals. You don't have to integrate. Remember, lice minus lift?
I need derive. I don't remember the formula. All I remember is lice minus lift. I don't remember.
Here, I got it.
That one.
It's a really useful formula.
So this is the differential equation, and that's the original population.
Oh.
Does that make sense?
Just
As applied to population, of course. So what did you guys find in number 8? Which ones match? I'm guessing that's the easiest way. That's what I would do, is just multiply them all out and see which ones work. Maybe that's not the easiest way.
I don't know what the answer is supposed to be.
But did any of them match up? That was the question.
Match with what though?
With each other.
Sorry.
Well, because, okay, hold on. So you're wondering like how to pick it out. So we know that this is equal to L, right? We know that this is equal to L times K. So I can say 40
2 over 20.
times K is equal to negative 0.032. Does that make sense? Because I can plug in L. So then what does K equal?
0.0008.
Positive? Or minus lift. Sorry, that'd be a positive. 0.008. See how I'm pulling it out?
Yeah.
So I have L and I have, so then using my formula from up above, I have K times Y and L minus Y. So number 1 is definitely true.
Yeah.
So forget that. And then, 1's in all of them. So then if we multiply,
So
40 times 0.008, move the decimal place 1 and we have 0.32. I think that ends up being 0.32, right?
Yeah.
So that's what I was saying on this one. So then you would have 0.032y minus 0.000y squared. So then now that you know this one's right, see if these ones work out to be the exact same thing when multiplied. Does that make sense?
Yeah.
Does anybody get 2 or 3 to match up?
That's supposed to be 0.0008.
Did I only put 1 0?
we're putting zeros now.
0.0008. Oh, thanks.
Yeah, number 2 is right.
Okay. It looks right because the 32, that wasn't for sure.
Well, then that would mean number 3 is right.
Yeah, because even though that, well, it could be 1 or 2. But if number 3 matches, then.
Well, I mean, it's just the opposite. The multiplication is just. Oh no, there's just 6 there. Never mind.
Yeah, no, that's the thing. I don't think that would work.
Let's double check that A.
No, because it's 0.151.
Okay, so just B.
Yes, ma'am.
What number is that? 8? Yeah, B's right.
Yeah.
Now, hold on. Number 9 is a very common logistic question to show up on an AP exam. Number 9 is a very common
Mistake.
question. It's not a mistake. Question to show up on an AP exam about logistic.
L over 2, right?
Yeah, it's L over 2.
Yep. What is L over 2?
40 over 2.
When it's increasing most rapidly, the time,
No.
not the time.
When the population is L over 2. When the population reaches half of the limiting constant is when it's increasing the fastest, because that's the point of inflection. That's where it switches from exponential to to the leveling off. So you have to set P of t equal to L over 2. L being 40. But that's not T. That's P.
Population, and we plug in.
Oh,
Does that make sense?
And what are we plugging that into?
We have to set that equal to the equation up above, but it's a graphing calculator problem, so we just set 20 equal to, and then find the intersection point for 40, and then 1 plus 6 e to the negative 0.032 t. Find the intersection point.
So 20 equals 40 over.
Does that make sense?
Oh, shizzle, my nizzle.
But do you see how that 20 is just like sitting there waiting to be chosen?
Yeah. So we have to solve. We just subtract it over and solve, right?
Yeah, you can do that, or you can just graph both sides and find the intersection. Or you can subtract the 20 and find the 0.
Oh, dang, that would be crap.
I know.
Mm-hmm. So hard to.
100 it is. Ah, Jackie's. Jackie, Did anybody else do 55 point us 66?
Yeah. That one on. So L over 2 is like the amount the population will be when it's increasing.
Exactly. Does that make sense?
Well, that's the fellas about to ring.
Not too bad, right?
Yeah, just like 6 problems that I've already
Okay, you guys got this.
knocked it out in like 20. You guys can do it fast. I knocked it out in like 20 minutes.
Want to knock it out for me in 20 minutes?
No, I'm good. No, it should be cheating.
Bye guys, see you later.
No, we thought we'd you right.
Gerardo, do you want to stop the video on your way out then?
Oh yeah.
Oh yeah.
Please like, comment, subscribe.
Yes. Like, comment, subscribe. All that jazz.
All that jazz, etc., etc.
Uh-huh.